Today we're going to put together all the different factoring methods that we've been working on. So far we've learned 8 different methods. Today we will learn our 9th method, which is u-substitution. U-substitution is a unique method that isn't all that difficult, so I'll save it until the end. What we'll want to talk about is when should we use what method. Of course, this is an essential question when you're going through, because you're going to want to think about what method to use and where to use it. Now, we say that a polynomial is factored completely if we have gone as far as we possibly can, and we cannot go any further. Thus, we cannot use a method again. There are plenty of techniques to kind of help you through this. I'm going to share a few with you right now. The first thing that you always want to look for is common monomials, otherwise known as GCFs. If you see a GCF, you need to take it out. Remembering, of course, that what you take out, you will put outside. Please don't forget this as you go through the problem, especially at the very end. After you have all your GCFs taken out, you'll want to think about special products. The special products that you're looking for are grouping, which talks about using or has 4 terms. If you see binomials, so just 2 things, you will want to use difference of squares, also known as DOS, or what we learned last class period, which is the sum and difference of cubes, where we use SOAP. Of course, SOAP stands for same, opposite, always positive. Say you're working through a problem and you've gone completely through the monomials and then you didn't identify any special products or binomials, then you'll want to look to see if there are any trinomials. Remember, trinomials, we are looking to see if A equals 1, in which case we use what? 2 numbers. And if it's not that case, then we have to do the guess and check method, which, of course, if we're using the guess and check method, we are doing it because A is not 1. This last part is huge. You need to look at your factors at the very end to see if you can do another type of factor. This idea is just like the extra credit problem that I gave. On the extra credit problem, that's where I had to use grouping, and then I had to factor a trinomial. I had to use 2 different factoring techniques inside one problem. This is what you want to keep an eye out for. All right, let's see if we can try some examples. If I start with my first one here, 2x squared minus 8. My first step is to think or look for a single GCF. When I look at this problem, I see that 2 can come out of both of these. So that's what I'm going to do. I'll take 2 out first. So I have 2 times the quantity, x squared, minus 4. As I look at the problem, I can see that the thing inside the parentheses right here is just a binomial. And furthermore, I can look at it, and I can see that x squared is a perfect square, as is 4. Because the first and the last are perfect squares, I think I'm ready to use difference of squares and take the square root of it. The square root of x squared would be x. First goes first, and then the square root of 4 would be 2. And last goes last. My sign, looking at this last sign, I know that they are going to be different. Because they are going to be different, I will put a negative and then a positive. And then I think that I'm ready to give my final solution, which I'll place over here in the open space as x minus 2 times x plus 2. And I won't forget to place my monomial on the side. Now would be a great time to pause the video if you wanted to try number 2 before I do. Okay, so now that you've worked through number 2, let's see if I can do this problem. As I look at it, I see that there are x's inside each of these terms. So I will take the x out, leaving me with x squared plus 6x plus 9. The next thing that I'm thinking is, are there any numbers that 1, 6, and 9 share? Of course, the answer to that is no. So I'm looking at my a value. My a value in this case is 1. Means that I should be able to factor this pretty easily. I know that these have to be x's to start. And now I'm just thinking about factors of 9, which are 1 and 9, and 3 and 3, that add because of this sign here, meaning that they are going to be the same signs. This sign tells you what kind they are. Thus, I know that they're both positives. And then I look at my factors over here on the side, and I see that 1 plus 9, that would be 10. I need a 6x. So it must be 3 and 3. Finally, I'm ready to write my final answer, which is x plus 3. Because it's x plus 3 twice, I think I'm okay with writing x plus 3 to the second power with my x, my monomial, on the outside. Now would be a great time to pause the video if you wanted to try problem number 3 on your own. Okay, now that you've had a chance to work out problem number 3, let's see if I can figure it out. When I look at this problem here, I see it's x to the 4th power. We haven't had a lot of experience working with x to the 4th power. However, if I write x to the 4th power, or instead of even writing it, if I just think about x to the 4th power, can I take the square root of x to the 4th power? Well, if we come over here to the side and I think about x squared. Back in last class, we talked about taking the square root of x squared, and that's just x. And of course, the logic behind that is because x times x equals x squared. Well, what if I think about my x to the 4th as x squared times x squared? Of course, that would be x to the 4th. Meaning that if I take the square root of x to the 4th, that's like cutting the power in half. Thus, the square root of x to the 4th should be x squared. Well, okay, that's first. So x to the 2nd should come first in each of my parentheses. Then I ask the question, is 81 a perfect square? Meaning, can I take the square root of 81? In this case, I think I can. So it is 9. I place those in there. My sign here tells me that they are different. One positive, one negative. And now, usually we would be done. But I see something over here in this binomial. I have a perfect square, x squared, first, and then I have a perfect square, 9, last. Because they are perfect, I have to do this again. I'm taking the square root of x squared, which is x. That comes first. I'm taking the square root of 9, which is 3. This negative sign here means that I have one positive and one negative. And then I simply drop down my binomial x squared plus 9 in front. I cannot factor x squared plus 9 because there is a plus sign. And not a negative, like I've had before. At this time, if you wanted to try number 4 on your own before I solve it, you need to stop the video. Okay, now that you've had a chance to work through number 4, let's see if we can do it together. When I look at this problem here, I see that 9 can come out of both of them. So if I take out a 9, I'm left with 9 times the quantity x cubed plus 1. I know that they didn't take an x out of both, so this must be a sum of cubes. I have a positive sign here, meaning sum, and then I have a power of 3, meaning cube, or cubic. Well, if I'm going to do this, thinking back to last class, that means that I have to create my little cubes. What power, or what number, should I put inside the parentheses, right here, so that when I take it to the third power, I will get x cubed? Well, we've talked about this last class, that's just next. Also, I'm thinking, what number should I place here so that when I take it to the third power, I get 1? Well, that's just a 1. And I drop down my positive sign. From here now, I'm just using that formula that we had before. Remembering, though, that this x is known as a in the formula, and this 1 is known as b. I know there's going to be a binomial and then a trinomial. I'm thinking through this problem here, so I have a, which is x, then b, which is 1. A squared, so that's x squared. A times b, so that's 1 times x. I think I can just write that out. That's just x. And then I have 1 squared here at the end, which of course is just 1. When I go to place the signs in there, I'm thinking so, which is S stands for the same. It was a positive sign over here, so it must be a positive sign here. O means opposite, so this is a negative. AP means always positive, so I place an addition sign. The last thing I can't forget is to take my monomial, that 9, out and put it outside. Then I feel like I am done with this problem. Remember, of course, that this trinomial at the end will never factor. If you wanted to give number 5 a try before I solve it, you should stop the video now and work it out. Okay, now that everybody's had a chance to try out number 5, let's see if I can give you the solution. I'm looking up here at it, and I think that they share a monomial. Now, 8 would be nice if it came out, but I don't think 8 goes into 28. But I do think 4 fits into them all. So 4 comes out, as does this x, since they all share an x. So then I have 4x times the quantity, 6x squared, minus 7x, plus 2. I now need to factor this trinomial. A in this case is 6 and not 1. Because A is not 1, I need to use the guess and check method. Well, the guess and check method means that I'm thinking about factors of this 6 to place first. Well, let's just guess here. Let's take 3x and 2x. Then I'm taking factors of 2 and placing them last. Well, let's try this thing out. Let's put a 2 here and then a 1 here. Finally, I'm going to check my signs, which because I have a positive sign here, I know that they're going to be the same. And then this negative sign here tells me that they are both going to be negative. I should always check my work since I'm guessing by doing the ends. So negative 1 times 2 would be negative 2x. And then the outs, 3x times negative 2 would be a negative 6x. Those combine to give me a negative 8x. And then I'm double checking that this negative 8x matches my middle term, which is a negative 7x. Clearly, that is not the same. Because I got a wrong number, I should first try to switch the numbers. Meaning I keep 3x and 2x, and I turn my 1 at the end into a 2, and then my 2 into a 1. Signs should still stay the same. And then I recheck. I check this here, negative 2 times 2x would give me a negative 4x. 3 times a negative 1 will give me negative 3x. Combine those and I get negative 7x, and I check it to the top portion, which does match up at negative 7x. It is important to remember what your answer looks like. Here is the factoring that ended up working. So I need to write that down. That's 3x minus 2, and then 2x minus 1. With, of course, my 4x, my monomial, placed on the outside. And that is my 5th example. Those are the only examples that I have for you as far as completely factoring. Of course, here we have a couple different ones where I use 2 methods, and I could use up to 4 or 5. Now would be a great time to pause the video and maybe work a few problems out on the worksheet if you would like. The last thing that I wanted to talk about today is u-substitution. This is our final factoring method. Yay, you should be excited about this. This is the 9th and final way. Sometimes you guys get overzealous in this method and you let it kind of freak you out. It's actually not that difficult. What you want to do is you want to use the name to help you. Here it says that I'm using substitution, meaning that I need to substitute something in for something else. I want to substitute in a u, and I want to replace it with something that seems obvious. when I look at example 1 here, the thing that sticks out to me are these x minus 3's. I want to actually pull those out. So if I take out x minus 3 and I replace it with a u, I'm replacing x plus 3 with u. Thus I have u to the second power, notice I didn't touch that squared, plus 10 times u plus 21. Here, if I try to color code it a little bit, this x minus 3 is this u. This x minus 3 is this u. Then I want you to think about this problem. Right here, this trinomial has its own little piece. When I look at it, a is 1. Thus, I should be able to factor this thing right away. Do I know factors of 21 that add to 10? Thinking through, yeah, I think that 7 and 3 do that. Okay, 7 and 3. Well, what do I place here and here? Well, before we placed x's there, because I had an x squared. This time it's u squared, so I must need to place u's here. Thinking back, this sign means that they're the same. This sign means, or tells you, what kind. So I should have two positive signs. Feel free to check your work, but I do believe that 7 plus 3 is this 10. After I replace it and factor it, I then need to go back and I have to put my original starter back in the game. My original starter, remember, was x plus 3. So I have to take x plus 3 and place them back into the game, which means I have an x plus 3 plus that 7 that was already in there, and an x plus 3 plus that 3. As you can see, all I've done is I've replaced u with x plus 3. If you look at the problem, I think you can simplify inside the two parentheses. I have 3 plus 7. Oh, that's simple enough. That's x plus 10. And 3 plus 3. Okay, that's x plus 6. And I have just solved my first u-substitution problem. If you wanted to try to give example number 2 a try before you see me work it out, now would be the time to stop the video. On example number 2 now, I'm going to follow the same type of steps. I see a g plus h. That to me stands out. Thus, I am going to let g plus h equal u. And I'm taking out all the g plus h's and I'm putting a u in their spot. So I would have a u squared minus 13 times u minus 30. Keeping everything else the same, just removing g plus h. Again, when I look at this trinomial here, u squared minus 13u minus 30, I see that a is 1. A being 1 should make this rather simple. I have u's here at the start. I'm thinking about factors of 30. Now, that subtract to give me 13. Well, let's make the factors of 30 real quick. Factors of 30 would be 1 and 30, 2 and 15, 3 and 10. 4 doesn't go into it. 5 does, though, 6 times. And then I would ask normally if 6 goes in there, but you can see I cross over to the other side, so I need to stop right there. Again, I said factors of 30 that subtract because these are different signs. Different signs. When I look at my list, I see that 2 and 15 would subtract to give me my 13. So I need a 15 and a 2. Signs are different, but if I'm going to get a negative 13, I'm going to need the bigger number, which is 15, to be the negative one. And I'm going to need the 2 to be the positive. My final step is to replace u with what we had in there originally, which is g plus h minus 15, and then g plus h plus 2. And there, circled at the bottom, is my final answer for the second problem. If you would like to try number 3 on your own, now would be the time to stop the video, that is, and work it out. Okay, now that I've given you a second to work through number 3, let's see if we can't do this. On number 3, I actually don't even want to use u-substitution if I don't have to. We talked about the idea of x to the 4th earlier, but that was with perfect squares. Here, let's just think about what happens when I have x squared plus blah x plus some number. Well, when we did that, we split it up into 2 parentheses and we placed x and x, because I know that x times x is going to give me x squared. Well, then the logic should follow that in order to get x to the 4th, all I need is x squared at the start. Then I think through factors of 10 that add to give me 7. I think we all know that that's 5 and 2. Signs should both be positive. And then if we don't feel very confident, we can always check our work. If I take the inside, that's 2 times x squared, that's 2x squared. And then x squared times 5, which would give me positive 5x squared, giving me a total of 7x squared, which hopefully matches this 7x squared up top. Don't forget what your answers should look like. This is x squared plus 2 times x squared plus 5. If you would like to try the 4th and final example on your own, now would be the time to pause the video. Okay, I guess I had another example in here. I didn't think that I had one more, but the more the merrier, as they say. Here on example 4, I don't see any GCFs in this, so I can't take anything out. But I do see this pesky to the 4th power, telling me that I'm going to have x squared pieced in here. I'm thinking of factors of 5, and I think that's just 5 and 1. Now I'm thinking about factors of 16 that I can use to combine with my factors of 5 and 1. Well, I think 4 and 4 sound like a pretty good start. So let's start with 4 and 4. Looking at my signs, I have a positive here, meaning the same sign, and then negative, meaning that they both will be negative. So I should have a negative and a negative. If I check my work here, negative 4 times x squared would be a negative 4x. 5x squared, times a negative 4 would be a negative 20x squared. And if I combine those, I do think that I get a negative 24x squared. This is great. And normally, we would be done. However, I need to look at my binomial. When I look at my first one here, this 5x squared minus 4, I don't think I can do anything with it because this 5 is not a perfect square. But as I look over here at my second binomial, I see that x squared is a perfect square, as is the last thing, 4. That means I can split this again. I'm taking the square root of x squared, giving me x, that goes first. Square root of 4, giving me 2, that goes last. Checking out my signs, I see this negative, meaning that the signs will be different. And I place in a positive and a negative. Please don't forget that you have a 5x squared minus 4 binomial to place out in front of it. And there would be our final solution. If you wanted to try my 5th example, you would need to pause the video now. Okay, this last example, I think I'm going to go through at a decent pace. I see that there's a binomial, and I see I got perfect squares sitting inside it. So I'm going to start by taking the square root of 16x to the 4th. Well, that's 4x squared. Of course, that needs to go first, so I place it in there first. Square root of 81, of course, is 9, and that goes last. Negative sign means that they're different. So I need to have one with a positive sign and one with a negative. Oh, but I got problems here. Because I can see, because I've done a couple of these now, that 4 and 9 are perfect squares. So I can do this binomial here on the right again. The square root of 4x squared would be 2x. That should go first. The square root of 9 is 3. That should go last. This negative sign tells me that they're different. So I place a positive and then a negative. I can't factor this binomial out on the left because of this pesky positive sign. So because of that, I just have to drop them down. And that's 4x squared plus 9. And I have factored out this binomial. That completes the notes for 4.7 u-substitution and the mixture of methods. Please, if you did not pick up on all the little methods and or were confused on some of the problems, listen to them again, rewind it, and if you still don't get it, ask me for some help.